Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to continue in Module 2 in the exam objectives by discussing Section 2.6, Virtualization and Cloud. Let's begin. We will start our discussion with virtualization. Virtualization is a technology that allows us to have one single host machine that can run multiple operating systems at the same time. Each individual operating system on a virtualized device is called a VM, a virtual machine. And each virtual machine will be a different instance of a specific operating system or workload that we want to have loaded and available on our host device. With virtualization, we use resource sharing. That means our host device's computing resources, such as CPU, memory, and storage, will all be distributed amongst the different VMs. Important tool whenever we need to deploy certain applications or services to multiple users. And it's widely used in our data centers and cloud computing, where we need to scale up and down different resources depending on the need and traffic of our users. The way that we manage all of our virtual machines and our virtualized environments is through a hypervisor. Hypervisors come in two different types, a software or firmware. A Type 1 hypervisor is a firmware version. This is a hypervisor that we call bare metal because we install firmware directly on the hardware device. The more common, which we use in our environments, are Type 2, which are software or hosted hypervisors. Will run with an existing operating system as its underlying infrastructure. And it's very easy to set up different VMs for CPU, memory, and storage allocation directly in the hypervisor's interface. Another aspect of a virtual environment is a guest operating system, or guest OS. Your guest OS is the operating system that is installed within a virtual machine. In our hypervisor, we can manage all of these guest operating systems. Your guest OS, even though it is a virtualized version of the operating system, will still operate as if it were on a dedicated physical host. We can have multiple guest operating systems running on the same host with different versions of the operating system, individual configurations that we can set for each VM. The performance of our guest operating systems will depend on how we allocate all of the resources that are available on the host device, making sure that all of our bandwidth is being used efficiently on the network. Next, we're going to discuss cloud computing, allowing our users to access certain resources over the internet in on-demand availability. This includes cloud storage, the use of applications through a web browser, accessing data on a server. All of these are use cases for cloud computing. The cloud refers to taking all of the hardware and infrastructure that will be on your own premises, in your own building, and moving them off-site and controlled by a third-party CSP, cloud service provider. CSPs are vendors that provide specific types of cloud resources such as storage, bandwidth, and applications, depending on the user's needs. Cloud computing is very popular because it's flexible. We can create environments based on the number of users we need, the types of resources that our users need to access, create different payment models with our CSP, such as pay-as-you-go, to keep our costs fixed. And each of these will provide a different service. Our first is PaaS, Platform as a Service. Platform as a Service is an environment for application development. It allows our cloud platforms to provide tools, code libraries, and the infrastructure needed to not only create, but test and deploy applications. Common examples of Platform as a Service include Google's App Engine and Microsoft's Azure App Service. Platform as a Service allows for faster coding. We can allow for microservices within our development team to allow individual developers to focus on specific services. And then our Platform as a Service can integrate all of the work that is completed by our development team. A second cloud service type is Infrastructure as a Service, IaaS. Infrastructure as a Service is allowing users to access computing resources for servers, storage, and networking over an internet connection. Storage is a very common use case for the cloud. We can store all of our sensitive data off-site through a CSP's hosted storage devices, and we can access them through our web browsers over the internet. Some common examples of infrastructure as a service include Google's Compute Engine, Amazon EC2, and Microsoft Azure VMs. The third service type in the cloud is Software as a Service, or SaaS. Software as a Service is allowing our end users to access software applications through a web browser over the internet. Your CSP will manage all of the infrastructure, application software, and updates. Some common examples that we use are Google's Workspace, Google Drive, and Microsoft 365, where we can access all of our Microsoft Office applications. Software as a Service is used for quick deployment of apps and to allow users to create subscription-based pricing depending on the length of time they need to access a software app. And lastly, we're going to discuss three common methods of deploying applications and services through the cloud. The first is on-premises deployment. On-premises deployment means all of our hardware, software applications, and data storage are hosted within our business's physical geographic location. On-premises deployment maintains full control. All of your hardware, software, and security policies will be managed in-house. It requires a significant financial investment because you have to purchase all of the hardware devices, software licenses, and the maintenance time from your staff. A second deployment type is a cloud deployment, hosting applications, services, and data on servers for our CSPs, our cloud service provider. A cloud deployment will reduce or eliminate altogether the need for on-site infrastructure. It's very scalable because we can allow the CSP to determine the availability of a resource. Having users that are working remotely, and we want them to have access to data anywhere that has an internet connection. One concern about a cloud deployment is we're giving up control. We are relying on the trustworthiness of the cloud service provider to provide security, encryption, and data sovereignty for all of our sensitive data. And lastly, we can have a mix. That is called a hybrid deployment. Hybrid means two different types that are integrated together. With a hybrid deployment, we will maintain our sensitive data on premises and allow all of our users to access more common tasks such as application uses and publicly shared data through a cloud environment. This allows workloads to be moved between environments as the status of data or the needs of a business change. Hybrid deployments are helpful if a business is transitioning to the cloud for the first time or with a new CSP and need to have some time to integrate their disaster recovery plans. That will conclude our discussion of Section 2.6, Virtualization and Cloud. In our next episode, we'll move on to Section 2.7 in the objectives and discuss Internet Service Types. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.